Before you scroll away, pause for 1 second because what you're about to hear changes how science understands the largest planet in our solar system. And if discoveries like this matter to you, tap like now so YouTube knows this kind of science deserves to be seen. For decades, Jupiter was considered a solved mystery, a giant ball of gas with predictable stripes, familiar storms, and one famous red spot that barely changed across generations of textbooks. But when the James Webb Space Telescope turned its infrared vision toward Jupiter, that comfortable certainty collapsed almost instantly. The images were not just clearer, they were fundamentally wrong compared to what scientists expected. Cloud structures appeared sharper than models allowed. Heat signatures were stronger than physics predicted. Patterns looked organized where chaos should exist. At first, engineers suspected an error. Calibration was checked, instruments were verified, everything was functioning perfectly. Which meant the problem wasn't Webb, it was our understanding of Jupiter. Instead of a passive gas giant, Webb revealed a planet driven by powerful internal engines, constantly redistributing heat and energy in ways that had never been observed before. This wasn't just weather, it was planetary-scale physics unfolding in real time. If you've ever wondered whether we truly understand the planets in our own solar system, this is your answer. Webb showed Jupiter glowing from within, radiating heat through concentrated channels rather than evenly across its surface. This immediately explained decades-old mysteries about why Jupiter emits more energy than it receives from the Sun. The heat wasn't leaking out randomly, it was being transported, focused, directed. And that realization alone forced scientists to rethink how giant planets work. But this was only the beginning, because as researchers looked deeper into the data, they found structures that didn't just challenge models, they contradicted them. The kind of discovery that doesn't tweak a theory, but breaks it. And if you want to see how quickly our assumptions can fall apart when new data arrives, stay with me, because what Webb saw next changed everything we thought we knew about Jupiter's atmosphere. What truly shocked scientists wasn't just Jupiter's heat, it was how organized that heat appeared to be. Instead of random turbulence, Webb revealed massive, coherent structures deep within the atmosphere, rising and falling like invisible pillars shaping the planet from the inside out. These thermal columns were hundreds of kilometers wide, powerful enough to influence storms on a planetary scale. If Earth had even one such structure, it would destabilize our entire climate. Jupiter has many. And if this kind of planetary physics fascinates you, hit like now. It tells the algorithm you want more real science, not recycled myths. As Webb's data sharpened, attention turned to Jupiter's poles. We've seen auroras before, but nothing prepared scientists for what Webb revealed. Vast electromagnetic vortices spiraled around the poles with astonishing symmetry, pulsing in rhythm with Jupiter's magnetic field. These weren't chaotic displays of charged particles. They were structured, synchronized, and persistent. For a brief moment, even seasoned researchers struggled to explain how something so orderly could emerge from such a violent environment. Then came the Great Red Spot. Long believed to be slowly fading, Webb showed it wasn't simply shrinking, it was reorganizing. Inside the storm, layered shell-like structures appeared, behaving almost like a system adapting to survive. Temperature measurements inside the storm exceeded anything previously recorded, reaching levels models said were impossible. This meant Jupiter's internal heat was not only active, but interacting directly with its storms in ways never observed before. The Great Red Spot wasn't dying, it was changing. And just when it seemed the surprises were over, Webb detected something deeply unsettling. Glowing filaments stretching across entire bands of Jupiter's atmosphere. They resembled lightning, but they didn't flash and vanish. They stayed, stable, pulsing with energy. These structures hinted at large-scale electrical or plasma processes operating continuously across the planet, processes no existing model could fully explain.
And this is the moment where Jupiter stopped being familiar and started becoming strange again.
As scientists pushed deeper into Webb's observations, Jupiter's night side delivered one of the most unexpected revelations of all. It wasn't dark, it glowed. Not with reflected sunlight, but with internal heat radiating upward through the atmosphere. Vast warm regions drifted beneath the cloud tops like hidden continents of energy, slowly moving and reshaping the planet's visible features. If this is surprising, like the video now, because discoveries like this rewrite what we think planets are capable of. These internal heat regions explained why Jupiter's storms can suddenly intensify, shift, or reorganize without warning. The planet wasn't reacting to surface weather. The surface was reacting to the interior. Even more astonishing were the massive atmospheric waves Webb detected, rippling across cloud layers for thousands of kilometers. These weren't ordinary wind patterns. They were gravity waves driven by deep internal activity, transferring energy upward and sculpting the atmosphere from below. Jupiter wasn't just chaotic, it was resonating, vibrating, almost humming with energy. Then came the lightning. Not the brief flashes previously seen by probes, but enormous electrical discharges originating deep within water ammonia layers far below the visible clouds. These megabolts erupted upward, illuminating entire regions of the atmosphere in a single burst. Their energy dwarfed anything seen before and confirmed that Jupiter's deep layers are far more active than surface observations ever suggested. Above it all, Webb revealed extensive hydrocarbon haze layers high in the atmosphere, absorbing radiation and trapping heat like a planetary blanket. This insulation effect may be the missing link explaining why Jupiter remains so hot after billions of years. Every new detail reinforced the same conclusion. Jupiter is not a simple gas giant. It is a complex, layered system where magnetism, heat, chemistry, and motion are tightly linked. And understanding it now matters more than ever because Jupiter is our closest example of a class of planets that dominate the galaxy.
The most profound implication of Webb's Jupiter images isn't about Jupiter at all. It's about everything beyond it. Gas giants are the most common type of planet in the universe, and for years our models of them were based largely on assumptions drawn from incomplete data. Webb just exposed how wrong those assumptions can be. If Jupiter, studied for centuries, visited by spacecraft, observed by countless telescopes, can still surprise us this deeply, then what does that say about planets orbiting distant stars? This is why these images matter. And if you appreciate science that actually changes how we see the universe, tap like before the video ends. Jupiter now appears less like a static object and more like a living system, constantly moving energy from its core to its clouds, shaping storms, auroras, and atmospheric patterns in ways we are only beginning to understand. The line between planetary interiors and atmospheres is blurrier than we ever imagined, and that realization directly affects how we interpret exoplanet data, how we model alien worlds, and how we search for habitable environments beyond Earth. Webb didn't just give us better pictures, it forced planetary science to evolve. Models will be rewritten, assumptions will be questioned, and Jupiter, once considered well understood, is now a frontier again. This is what real discovery looks like, not flashy speculation, but quiet data that dismantles certainty. And as Webb continues to observe not just Jupiter, but planets across the galaxy, one thing is now clear. The universe is far more dynamic, far more complex, and far less predictable than we ever believed. Jupiter was never what we thought, and after this, neither is the cosmos.